Welcome back. The objective of this video is to write an equation of a sinusoidal function given its graph. So here in example 12, it says find the equation for each graph, state the amplitude, period, phase shift, midline, verify your equation with your graphing utility, so you'll need your graphing calculator and we'll do that. State the maximum and minimum points in one period and the points of inflection. So here we have our graph. And it appears to start at a y value of 3 at an x value of 0 radians. But this graph goes down. It starts at 0, and so this looks like a negative sine function to me. It appears we've got a midline at 3. So if I put my midline in at 3 here, you might see a negative sine function that completes its entire cycle between 0 and 4 pi. So we can answer some of our questions. Our midline, it appears that that's at y equals 3. We've got an amplitude of 2, and our period is 4 pi. Our maximum value is at 5, or at, you could say, at 3 pi, 5. And our minimum value is at 1, or at pi 1. So we have some of our equation already. We have an amplitude of 2, but we're going down. So I'm going to say that's going to be, our function is going to be y equals -2 sine. And now we've got to do, take care of our x and figure out we've got our period, but we have to figure out our b value. So we know that 4 pi equals 2 pi over b. We can do some algebra, or we might eyeball it, but we can see here that b is equal to 1/2. If we divide by b, yep, we'll get, divide by 1/2, we will get 4 pi. So sine of 1/2. There's been no phase shift here. We haven't shifted left or right, so we can just do 1/2 x. But we do have a horizontal shift up 3 units, so we've shifted up 3 units because our midline of 3. Now our inflection points are when we change from concave up to concave down, or vice versa. So we have a change in concavity. And those points are the points on our midline. So our inflection points begin at 0 and a y value of 3. But they occur every 2 pi. So 0 plus 2 pi k, and that would, k is for the number of times that number of cycles we go through. So I would say our inflection points are 0, 3, and then 0 plus 2 pi, because every single 2 pi for every half of our cycle here, we have a change in concavity. Now let's flip over to our graphing calculator. We'll put our function in and we'll set our window. So let's remember to steal our window here and go ahead and graph this on the graphing calculator. Now going over to my graphing calculator, I've input my function, -2 sine of 1/2 x plus 3. I am in radian mode, so if you're not, go to the mode key, cursor down to radian and select that. And now let's go ahead and set our window. I'm going to set my window from negative pi, so negative second, and then the pi key. And I'm going to do an x max of 7 pi. And we can count by ones, that's fine. And our y min might be negative 5. And our y max, I think it was 6, so we'll go up to 10. And we can count by ones there again. And we graph our function. And there is our sine curve. I suppose we could get cute and we could graph our midline at y equals 3. And there's our midline. And there's the graph of our function. And in hindsight, it might have been nice for my scale on my x-axis to be pi over 2. And you can do that. I can just do second pi divided by 2. And I can count by pi over 2's. And now you can see our x values match up better with the graph of our function. Now let's turn our attention to example B, and we'll answer those exact same questions. It looks like we've got a pretty good amplitude here. We're going from negative 6 on the y to 2 on the y, so we've got a total height of 8 units. So 4 must be our amplitude here, and it looks like we would have a midline at negative 2. So I've got my midline at y equals negative 2. My maximum occurs at 2. My minimum is at negative 6. And this appears to be a cosine curve because we're starting at our minimum and going up. So this is actually a negative cosine curve. And we've got an amplitude of 4. So negative 4 cosine and some x, and then our midline is at y equals negative 2, so this graph has been shifted down to 2 units. So I've got all that information for my equation already. It looks like we're starting at our negative, so there's no phase shift, or we can do this one without a phase shift, and we go through the entire cycle between 0 and pi. So our period is pi. So we've done a squeeze or a squeeze of this period. And so now we can figure out what our b value is going to be in our function. So setting our period pi equal to 2 pi over b. And in order for that to work, their b value must be 2. 2 over 2 is going to give us a period of pi. So this is for cosine of 2x. If I start here at 0. There are other possibilities. We could do a phase shift to the right of pi over 4, and this could be a sine curve then with a phase shift of pi over 4. So we could also see this as y equals positive 4 sine of 2 times x minus the quantity pi over 4 minus 2. But then here we'd have a phase shift. If it's sine, we'd have a phase shift of pi over 4 to the right. So it depends on what you choose. If you choose a cosine curve, there's no phase shift. Or if you choose a sine curve, then we have a phase shift pi over 4 to the right. And then also that would impact our inflection points. Let's do the inflection points for our cosine curve. Our inflection points here are going to occur at pi over 4, and then 1 pi over 4, 2 pi over, and at 3 pi over 4, and 5 pi over 4. So our inflection points are going to begin at pi over 4 plus every pi over 2k, and then at a height of -2. And now let's go ahead and take a quick look at this on the graphing calculator and see what that looks like. So here I have input my cosine function, -4 cosine of 2x minus 2, my sine function for sine of 2x minus pi over 2 minus 2, and I did my midline of y equals -2. Now let's go ahead and set our window and make sure that's appropriate and take a look at our function. So my x minimum value, I'm going to go from -pi over 2 and my x max, I'm going to go all the way out to 2 pi. My scale, I'm going to do pi over 4, so second pi divided by 4. And then for my y's, I'm going to go from like -10 to about 8, and we'll count by ones, and we'll go ahead and graph that. And there are two functions, and everything works out, and it matches up with our other graph. And so there you go. We've written some equations given the graph of the function, and you'll get some more practice with this when I see you in class.